Namaste, welcome to Sthita Pragna channel. We are in episode 3. I hope you enjoyed episode 1 and 2. In this episode, you will learn how to use Spark Scala shell. Previously, in last two videos, we have seen PySpark shell, but today we are going to see Spark Scala shell and its friends again PySpark a little bit and Spark SQL for fast interactive data exploration. We will cover the most useful shell commands, tab completion, checking your Spark version, which we have seen in PySpark, loading data with high-level structured APIs, a quick Scala warm-up, and a tour of the Spark UI. By the end, you will be comfortable launching shells locally, running commands, and understanding what's happening under the hood. Perfect for rapid prototyping and learning Spark. Okay, so what are we going to learn? How to start Spark shells locally, essential shell commands, tab completion tips, read files with data frames. Maybe we'll see or we will not, we'll see. Scala basics inside the Spark shell and Spark UI tour. Now, what the question arises, what is the Spark Scala shell? Well, it is an interactive environment built on Scala's REPL. When you run it, you are effectively launching a Spark application that lets you call Spark Scala APIs interactively. That interactivity is perfect for exploratory data analysis and for learning Spark and Scala together. The same idea applies to other shells like PySpark, which we have seen, and Spark SQL and Spark R. The shell runs Spark in local mode by default when you start it on your laptop. Structured APIs, data frames, and Spark SQL sit at a high level. Spark compiles them into optimized RDD operations and bytecode behind the scenes. Got it? Once your Spark Scala shell is open, your first stop is the built-in help. Now, how do you open Spark Scala shell though? Not from here. So we'll go here. And how do you go there? /bin and Spark shell. That's how you open. This looks similar to PySpark though, like log level is warning, and you can see the SC and Spark created, you can see the UI, but additional thing it will show is instead of Spark, Python, it will show you the Scala version, which is 2.12. Got it? Now, we will run .help. Why? Because this command helps you to see everything the shell supports, as you can see here, right? It lists commands like history, load, reset, silent, quit, and type. We will use several of these shortly, but if you want to see, this is how you do it. Colon, help. And tab completion is awesome, and you need to know that. What is that? The shell supports tab completion like your favorite IDE, so you can discover methods and reduce typos. Try completing a partially typed word. You have seen me do this, but you might thought it was magic, but it is not magic. Uh, for example, see, if I only entered spa and hit tab, it will fill it for me. Since there are two items that matched, it gave me two. Okay. If it only matches one like this, it will only give me one and it will fill it up. That's what tab completion is. The shell completes spa to Spark and shows possible matches. You can also use tab after an object to see members and methods. For example, if you type Spark, then press tab to list what's available that we have already seen. Spark is a pre-initialized Spark session in the Scala shell, just like you would see it in PySpark shell. And let me show you some common commands. You will use a lot. You will use these a lot, what they do and when to use them. Okay. So history, you might have already guessed, shows commands you ran in previous and current sessions. I only ran these here. This is handy for copy paste. And then you have load. This executes code from a file, which is great for longer logic you want to load into the shell, right? Let's assume that you are working on an application. You will use the Spark shell to test each line at a time. Once you tested all the lines, you want to put it in a script and execute all those lines at the same time. So you will use this to do that. And then you have reset. This resets the shell back to a clean state if you have been experimenting a lot. Like it will clean up all the cached stuff and etc. And then you have, it's okay, that's fine. Silent. This toggles output display if you want less noise. And then you have quit. It's like exit, which exits the shell. And colon exit won't work, so don't try it. And then you have type. And then you will give a variable name. This prints the type of a variable. This is super helpful when you forget types. Okay. And another tip is you can use your up arrow on your keyboard to recall and rerun previous commands quickly. Got it? Now, Spark ships multiple interactive shells. We already know that. And we already saw how to run PySpark. And now you just saw how to run Scala. If you installed from PyPy, you can just run PySpark directly. That will open up, but we didn't do that. So that's fine. Let's start a PySpark session here. Again, I mean, in the previous video, we have seen it, but let's do it here. It will be similar. It will be similar to Scala, right? And we have also ran the Spark shell as well, so no, don't worry about it. And we have seen the banner, a note that the Spark contest web UI is available, SC and Spark set, and a prompt for expressions. And you can, if you want to double check your versions, what you can do is you can type spark.version. Here it will show you that, and same command. And you will notice that I'm going to show you code in both Scala, Python, and R and Java and all. You will see Scala and Python are almost similar in so many cases. That's why I insist on you guys to learn both, not to stick to one. Okay, now let's read a text file into a data frame and show the first 10 lines without truncation and count rows. This uses Spark's high-level structured APIs, not raw RDDs. And I told you we will cover about RDDs in intermediate uh, playlist, not in the beginner. Okay. And we don't have to worry about, oh, where should I get the file from? That's fine. We have a file readme.md file, remember, in the Spark home directory. So we are going to use that. And Scala, we will have Scala Essentials course in chapter 4. So whatever I execute till then, just go with it. And it's not like Python. It won't automatically infer the data type based on the value. Instead, you need to tell it what value you are going to put in your variable. So let's create strings. And we use this, right? Spark.read.text, because it's we are going to read a text file. The readme file is a text, and where is it? It's in a directory. We are in bin, so we need to go back one folder, and then I don't know. You cannot tab here. Okay, that's it. What does it do? Oh, it didn't find the path. Oh, it's going into there. Okay, let's not do that then. Maybe this. Okay. Yeah, it's in that folder. Actually, we are in that folder. I forgot about it. We are not in the bin folder. So what did this do? It created a data frame named strings with a single column value. You can see that here, right? To preview the first 10 rows without truncation, we have already seen this. If you want to show the first 10, you can just type str, tab it, and it will show you all those. So it looks like there are multiple. Then you will use the show. But the problem with the show is it will truncate. As you can see, it won't show completely, so that you can avoid by saying truncate false. And by the way, be careful about how you give it. You can just give, if you want to see 10 rows, you will see 10, but it will still show you the truncated version of it. And then you can give the value false. Okay, so now it is showing 10 rows without truncating it. Now let's run another command, which is going to be strings dot. Let's see how many records are there. So you are just going to issue the count, and it is going to be long equals to 125. So this is telling that it's a long type result for the number of lines. This same pattern, read, preview, aggregate, is the bread and butter of interactive exploration. Got it? Now, if you are wondering how to do this in PySpark, right? Identical workflow using PySpark shell, you will notice the near one-to-one parity. You won't believe me. I will execute it and show you one-to-one parity between Scala and Python. Seriously, if we have to repeat the same things here, what should I do first? We have to read it. In Scala, you said it's going to be a val, but we are going to not we are not going to do that here. Okay. Instead, we will just say strings, but the command, see, it will be spark, read, text. There is no difference in that. And you are going to give the same thing. Okay, your strings will be created. Now you want to see top 10, and it's going to be the same. It will truncate it if you do the show. See, now if you try to do this, it will fail because Spark won't recognize lowercase false. It has to be capital, sorry, capital F. Got it? So that's the difference between Scala and Spark, but it's a minor one. It has to be capital F, but it's still the same command. Is there any difference between Scala and Spark? Not much. And if you want to do counts, it's the same. Same command, instead of long equals to, it will just give you that number 125, right? So what did you notice from these commands here? That Scala commands and Spark commands are almost 90% same. Now, I have mentioned something called structured APIs a minute ago, but what are they? Structured APIs are nothing but you call them data frames and Spark SQL. They are structured APIs which work with structured data. That's why they are higher level and more conscious than direct RDD code. RDD is lower level, okay, whereas these are higher levels. Since Spark 2.x, this is the preferred way to build most workloads. Under the hood, Spark compiles your structured API logic into optimized RDD operations and ultimately into JVM bytecode executed by the clusters executors. You don't see the that generated RDD code, it's internal, but you benefit from its optimization. You might have used several tools like this. For example, if you have heard about Informatica or Talend, you will drag and drop behind the scenes, it will generate the code in Java, right? Same thing, I guess. Informatica is, it will, even you drag and drop behind the scenes, it's Excel. I guess it gets converted later on. XML, sorry, not Excel. The point here is, even though you are writing that in data frames and Spark SQL, behind the scenes, Spark will convert that for you in RDD, and then RDDs get converted into the bytecode that the machine understands. Got it? You don't have to know all that, but it does it internally. You don't need to be a Scala expert to use the Scala shell, but knowing a few basics really helps. Okay, that's what I'm trying to tell you. That's why I designed a specific course called Scala Beginner Essentials and Python Essentials. Even if you are new to Python, that's fine. I have explained enough about these tools so that you can get started or use Spark. You don't have to learn completely. They will be in the chapter 4. They are dedicated for those. So don't worry about it until then. Okay, but until then, till that chapter 4, let's warm up with a few quick examples. So let's go here and do println. Println is common for Java. So Scala is a Java based program, so that works here as well. You can type hello from Spark Scala shell. Okay, so it printed that println. That's what basically it does. This is the classic hello world. Next, let's define an immutable array of ages. So you need to do val ages. Let's create an array 20, 50, doesn't matter, some ages. Okay, it says array of integers, and you can see that immutable means you cannot change it. This particular ages, you can use it to make another one, but you cannot change this. Mutable means you can change it. Okay, and you can try tab completion here as well. For example, if you type ages, oops, ages dot fo, then it will show you all the functions that are available for an array. This tab completion is very useful in these cases. Okay, and you can see for each, right, which is the one I want. So let's go ahead and ages dot for each, and sorry, ages, and it will fill it for you. And then I am going to put print ln. What are we telling? We are telling print each of the item in the ages array. That's what it did. Now let's define a small function that returns true if an age is odd, false otherwise. Note that Scala infers the return value from the last expression. No return keyword is necessary here. So how do we do that? Let's say diff or definition, and let's name it odd age, and you are going to give an input which is going to be age, and it's going to be an integer, and the return value is a boolean. And what is it? It's going to how are we checking it? If you want to check if it is odd or even, you use percentile, which is a modulus symbol 2. Technically, this modulus means the remainder. When you divide a certain number with 2, if the remainder is 0, it is even. If it is not 0, of course, you are going to get 1. Then it is odd. So that's what it is doing. That's it. Let's enter it. Okay. Now you can call this particular function using our ages array. Right. We will use a filter with a lambda to keep only odd ages. Then print them in one chained expression. You can do that. Okay. So how do you do that? You can even do, oh, sorry. Okay, you can type this. It says it's true because that is an odd age. You can try something like that, but we are going to use our array that we created previously, which is the ages. So we are saying ages, let's filter it. How are we filtering it? We are telling list only odd ages from that array of ages. So we are telling this should be odd age. And then what is our input? So you can imagine this, right? This is a lambda function, but in Scala. We are telling filter, but how the age, whatever age is, right, it will pick one at a time and it's naming it as age, and we are passing that age to this function. Okay, so we are doing all that in this one simple statement, and then we are telling whatever output we get. For example, if I just enter this here, then you will only see 35 and 41 from ages. Do you remember what are there in the ages? We have all this, but 20 and 50 are even. That's why it didn't show. So this one, you created a lambda function. So ages, each one is converted into age, and then we pass that to the function. And whatever is odd, so technically it will say this is false, false, true, true. So when this is true, it will send it to the filter and then it will print it. That's what we are doing for each. And we will use the same command that we did before, println, right? To print it on each line. Here it printed it as an array, but here it printed as a value. Chaining like this is very common in Scala. right? Filter to narrow data, then for each to act on it. When you forget the exact type of a variable or function return, all you need to do is, what is it? Type, colon type. If you say Spark, it will tell you what type it is. It is a Spark session. That confirms Spark is your Spark session, the main entry point to reading data and managing configs. Interesting. So this is just a warm up, not anything relevant yet. I just wanted to warm up with you how Spark commands look like. Now let's take a look at the Spark UI, shall we? When we started the shell, Spark printed a line like Spark context web UI available at http colon IP 4040 etc. Let's open that URL in the browser while the application is running to see the Spark UI. Since we ran it here and in PySpark, it might have shown different port numbers. Okay, 215 40 41. Do we have it open? No. Okay, here we have it. Okay, and looks like some jobs are already here, right? So this is a live dashboard for monitoring and debugging jobs, stages, storage, environment, executors, and SQL. Okay, the job, stages, and SQL understand DAGs, tasks, and SQL query plans. Okay, that's what basically this will show you. All of this. And then you have the storage. Here you can see cached, persisted RDDs or data frames, but we didn't do anything, so you won't see anything. And in the environment, here it will show you the runtime info like Java, Scala versions, and Spark properties like basic plus advanced, Hadoop properties, system props, and class path entries, all that is showed here. And under executors, will show you per executor metrics like memory, disk, CPU, and overall summary. And we only have driver. We are running. This is local, right? So only driver it ran, nothing else. Remember that this UI will only exist while your Spark app is running. Got it? If you don't have your app running, then you won't see this here. And you already see some jobs here because these are the jobs that I just ran, right? The count and etc. show count etc. These are the jobs. The Scala shell predefines Spark. Our Spark session, and from there we checked versions, list configurations, and discovered available members via the tab completion, right? And we printed the Spark version and all that awesome stuff we have seen. And let's see what else. What did we learn here? We have seen or just at least got warmed up to the Scala commands, and now you know there exists a Spark UI and what each one of these will show you, right? So you can see the DAGs here. It scanned the text and does all this. And don't worry about this. I will explain you this in the intermediate playlist, not in the beginner. We'll talk about each and everything here. Don't worry about all this right now. You don't want to be uh, scared by looking at all these things. So in the beginner, I'm not going to cover all of that. Got it? So that concludes this particular video. We are slowly progressing, and that's what I want to do here at this point because there are so many things to explain, and we have seen a couple of them here. We have seen Scala shell and couple of Scala commands and whatnot. So in the next video you are going to have some fun with Docker containers, setting up Docker and etc. So see you in the next one, and don't forget to do the quiz and also the interview questions, which will be provided. The links will be provided in the description. Each episode will have those, and wherever we have code, that video will also have exercise questions. And of course I am going to provide you solution, but I would want you to practice first, then compare it against the solutions. Don't look at the solutions immediately. That being said, see you in the next video. Have a great day. Peace out and love you all.